In this video, we will go over section 8.2, testing the difference between means for independent samples when the population standard deviations are unknown. So if you don't know what population standard deviations are, you have to go with Ttest from chapter 7, right? So we're not doing any Z-test in chapter 8 because we're going to just assume either they are equal or unequal. And in fact, I think we only have to cover the types that where the population variances are assumed unequal from the course objectives. But I think I got both examples, when they are assumed equal and when they are assumed unequal. And depends, we have to click on one button that says pooled or not pooled. So we'll see those cases. But I just realized that we only really have to look at the cases where population variance or standard deviations are assumed unequal. It's all right. So let's get started on this. But what I screenshotted over here is the tool that you're going to use for all the problems in section 8.2. Okay, when you do Tstat, to sample, either click on with data or with summary. You're gonna have to just enter some summary in there if it's not a list of data, but you will have to come up with the hypothesis yourself. Okay, and then once you get your p-value, you have to know how to interpret it. So that's what we're going to focus on in section 8.2. So here's the learning objective for section 8.2, how to perform a t-test. And I just showed you. This is how we're going to perform a t-test, okay? I'm going to skip the test statistic method. We're not going to do anything by formula, because this will take care of it for us. We're going to just focus on making the conclusion from the calculated p-value. How to perform a t-test for the difference between two means mu1 and mu2. This is mu1, which stands for average of the first population, and mu2 is the average from the second population with independent samples with unknown population standard deviations. Okay, so let's start with some examples. And the reason we're using t-test is because these population standard deviations are unknown. All right, so two sample t-test is used to test the difference between two population means, mu1 and mu2. So we start using subscripts now, right? Mu1 stands for the population of, the average or mean of the first population, and mu2 is the average or mean of the second population, okay? The case or the assumptions that mu2 and mu2 are unknown, change that typo for me. Or I will change that for everyone. What does that say? So I'll change it right now. There we go. This looks lower than the other one for some reason. Well, that's okay. Let me present again. So when the population standard deviations are unknown, we're going to use t-test, okay? Samples, of course, have to be have to be random. If the samples were not random, we cannot make a conclusion about the bigger population. So it has to be random. Samples are independent. If they are dependent, we're going to use a different test. So that's for 8.3, and we plan on going over that during class next week. But for this test, samples are going to be independent, and the populations are normally distributed, or using the central limit theorem, at least the sample sizes are greater. Give me 1 second. So both sample size 1 and sample size 2 has to be greater than or equal to 30. Okay? This is a slide that I added. Okay? There is part about pooled variance or pooled standard deviation when you use this function in StatCrunch. And we'll see. Sometimes we have to click to pool the variance or standard deviation, or we don't click. I want to tell you when you do that. So let me show you real quick. So if I open up StatCrunch, this must be from our class. Take a look. I'm going to stat, Tstats, 2 samples, and I'm going to click on with summary, okay? With summary. So you're going to enter the information in here, like sample 1, what's the mean, what's the sample standard deviation, not the population standard deviation, right? And what's the sample size? You do that for sample 1, and you do that for your sample 2. But take a look, there is a calculation options. Pool variance. Note the default was recently changed to off. So when do you click on it, and when do you not click on it? Okay, so that's why I'm asking you to look at this slide with me, because sometimes you have to click on pool variances. Sometimes you shouldn't click on it, okay? So take a look right here for me in that Google slide, number 16. When population variances are assumed equal, okay, we don't know them, but if somewhere in the problem it's telling you that you can assume population variances are equal, then information from the 2 samples is combined to calculate a pooled estimate of the standard deviation S hat. I don't know why the hat is outside. The triangular hat has to be on top of S. So I don't know how to I'll try to fix this later. So in short, you click on pooled variance. Okay, you do this pooled variance when population variances are assumed equal. And I found some extra resources on what is pooled variance. You can click on this and read a little more about this. The pooled variance is an average of group variances. You can read a little more about this, but when do you click on pool variances when you're doing StatCrunch? Somewhere in the problem, if they mention assume population variances are equal, then you click on pool variance. You know what I just realized, you guys, so I think our 245, Nova, 245, we don't really need to pool variance at all because of the learning objective that says population variances are assumed unequal. But I think I got some examples in a homework that you have to pool the variance. So, but I did go over it. So we can probably look at 2 different examples on this Google slide. But when do you, and I think I made this into a attendance quiz, because that little button, whether you click on or you don't click on, could make a difference in your answer. So how about I take a look at that attendance quiz number 1 with you together. I'm just going to go into my Wednesday group. The Friday group is going to have the same attendance quiz. Hold on, Luna. I'm going to go into student view, and then I will open up attendance quiz for 2 sample part 1 attendance quiz. Okay, so the first question, what? Whoopsie, I already answered it. I already did it. So question number 1, when doing a 2 sample variance procedure, we pull variance when population standard deviations are equal. Okay, so that is the first question. Okay, going back to the slide. There are a couple more questions. That I want you to complete. Back to the slide. Example number 1. Okay, 2 sample t-test for the difference between means. Let's take a look. The result of a state mathematics test, oh, those SOLs, huh? For random samples of students taught by 2 different teachers at the same school are shown below. How evil. I don't know. Why are they looking at this? Why are they comparing teacher? I don't know. Is this teacher performance? Not really, right? Can you say that a teacher is a good teacher just by looking at their students' test scores? But hey, for some reason we're looking at this. So what are we doing? Can you conclude that there is a difference in the mean mathematics test scores for the students of the two teachers? Use alpha level 0.10. Assume the populations are normally distributed. Thank goodness, because if they didn't say that the populations are normally distributed, what was the second condition? We needed both sample sizes to be at least 30. And what I look in this table is that teacher 1 taught how many students? 8 students, okay? Or at least 8 of them tested. Teacher 2 only had how many students? 18 students. So we almost couldn't do the t-test, but they did tell us that populations are normally distributed. So we're okay there. Whew. Okay. If they don't have that part, assume the populations are normally distributed, then you must have both sample sizes greater than or equal to 30. And they said population variances are not equal. So what does that mean? The very last part that I just read. Population variances are not equal. You're going to click, or you're not going to click on pool variance. Okay, don't click on pool variance when the population variances are not equal. I think there's another example later on that we're going to look at where population variances are assumed to be equal. In that case, we click on pool variance, not this time. So take a look. Teacher 1 and teacher 2. I can see X bar 1, the average of students that teacher 1 taught was 473 compared to this teacher number 2 who taught 18 students, and the 18 students had an average of 459. I don't know if this is like an SOL score, but is this passing advanced? Can't remember. But just by the look of this, you guys, students in teacher 1 class, they did a little bit better, don't you think? X bar is higher. 473 is higher than 459. But is that statistically significant? Is their difference statistically significant? See, it could just be because of the sampling error, right? So we're going to do a hypothesis test at alpha level 10%, okay? So how do we do this? I don't know if I took a screenshot of this already. I didn't. That's perfect. So that you and I can do this together. Oh, what is this? I'll read this. Note that population standard deviation from test teacher 1 and teacher 2 are unknown. The samples are random and independent. They're independent because one group was from teacher 1, the other group was from teacher 2. And the populations are normally distributed. So, the very first sentence that we just read, that was checking the conditions for t-test. So we're good to use the t-test. The claim is there is a difference, that they are different. So they're not equal to. We're not saying teacher 1 did better. We're not saying teacher 2 did better. We're just saying there is a difference. Okay, do you know the symbol for equal to, right? The different means not equal to. So what we're going to do is equal sign, we're going to put a slash through it. So the claim is there is a difference in the mean mathematics test scores for the students of the two teachers. So here are the hypotheses, okay? No one has to assume that they are equal. They have no difference. So we're going to say mu1 equals mu2. That's the null hypothesis. The alternative hypothesis is going to assume that they're simply different. So what's the symbol for different or not the same? Mu1 does not equal to mu2. So the claim here is the alternative, but this is the hypothesis that you and I will have to enter. Okay, you ready? Let's do this together, okay? Because I don't think I included the z-score method. I'm sorry, the test statistic method in this Google slide. Oh, hey, some of you are in here. Okay, so go back to this slide with all those numbers. Okay, I'm going to open up StatCrunch. Where are you? I have so many tabs open, you guys. Oh, here it is. And I'll start from the beginning, okay? How about I bring this browser out and move it like this so that I can look at both screens at the same time. I am going to Ttest to sample and click on with summary. Okay, that's where you go. And on this screen, let's enter teacher 1's information in sample 1. The sample mean was 473. The standard deviation is 39.7. Sample size is 8. She had a smaller sample. Sample mean for teacher number 2 is 459. The sample standard deviation, remember this is not population standard deviation. This is not little lowercase sigma. This is lowercase s, 24.5. And the sample size is 18. You notice that I just literally entered all those information exactly the same, right? Now this part though. Do I click on pull variances? Yes or no? No. Why not? Because population variances are not equal. We're not going to pull them. So do not click on this box. Do not click on this box. Now, for the hypothesis, we were assuming that they are equal. Now, listen to this for me. If they are equal, if they are the same thing, think of something that are the same, like 5 and 5. 5 equals 5, right? What happens if you do 5 minus 5? If you subtract something from the same exact thing, you see it equals 0, right? So, saying that mu1 equals mu2 is the same as mu1 minus mu2 equals 0. What we're trying to say is there is no difference. And no difference means the same, right? So that is the null hypothesis. And what was the alternative hypothesis? It was a two-sided test, right? So we're going to keep that as not equal to. Not equal to. All right, and I'm done. I'm going to go ahead and click on compute. But before I do that, let me take a screenshot of this so that when someone is just reading the slide instead of watching this video, they know exactly what to enter. So here is the screenshot of what went into my StatCrunch just now. All right, after I hit the compute button, I'm going to get an output table to matches that information. Okay, I'm ready. Compute. And I will take a screenshot of this table. And I'll put it right here so that you and I can look at it together. Okay? So it says, because p-value is greater than alpha 0.1. What is a p-value? Let me zoom in. P-value is let me write that down. P-value equals 0.3792. That's like 37.92%. That's definitely greater than 10%. Because this p-value is greater than the set alpha level of 0.10, we have to say we failed to reject the null hypothesis. Null, what was null about? Null was saying that they're the same. So we reject that they are the same. So what does that mean? Whoopsie. I'm sorry, I was saying the wrong thing. We failed to reject because the p was so big, right? So this test is inconclusive. We don't really have any statistical evidence. This is not fun. So we have to tell them that there is not enough evidence. Okay, there's not enough evidence. I'm gonna go ahead and highlight this. And what else is important? That we failed to reject because the p-value was greater. So when you're doing your test, you want that p-value to be small, right? But because p-value was greater than the alpha level, we failed to reject the null. Hypothesis. So I guess I'm not gonna say we accept the null hypothesis. We never accept when you're doing hypothesis. We just are gonna say we failed to reject it. Okay, so there is not enough evidence at the 10% level of significance to support the claim that the mean mathematics test scores for the students of two teachers are different. Okay? So inconclusive. We don't really have a conclusion. Alrighty, let's look at another example. Hopefully, the second example, we have a successful hypothesis test. Because this one was boring. It wasn't, but I guess I'm okay too because we just saw that two teachers, I mean, we wanted to compare teacher performance or what, how their students did, and I don't really have any evidence to prove that they are different, or so I guess I'm okay. We don't have a conclusive decision on example number 1, but I'm okay with that. All right, let's do example number 2. All right, hold on. Maybe after example number 2, I will stop this video, okay? And then I will come back and do the confidence interval in another video. All right, hold on. Example number 2. A manufacturer claims that the mean driving cost per mile of its sedan is less than that of its leading competitors. Competitors. I swear my English is getting so worse, So what they are saying is they have less mileage, right, in their car, and that's a good thing. Because if you live in Northern Virginia, right, don't you commute a lot, right? I have to commute from Fredericksburg to Woodbridge when the school opens back again. So if that happens, I probably shouldn't drive my minivan or a big truck to save money on gas. So what they are saying is their car's better. Their car has smaller or less, their car has lower miles per gallon, cost per mile. It's just cheaper on gas. So what do they say? But listen, that's what they claim, right? They said it's less than. You see, this is going to be a one-sided test. Okay, they are saying it is less than. So remember, we're going to have to change the symbol to less than symbol when we write this alternative, because that's what they are claiming here. It's less than. They're not saying it's greater than, or they're not saying it's different from. You conduct a study using 30 randomly selected sedan from the manufacturer and 32 from the leading competitor. I like that sample size, don't you? 30 and 32. I can use the central limit theorem. I don't need to know if the populations are normally distributed. Because the sample size is 30 and 32, we're good to go. From the leading competitors. Okay, so I read that part. The results are shown at alpha equals 0.05. So we're comparing our p-value to 0.05 when we get that p-value later. So we want our number to be less than 0.05, right? Can you support the manufacturer's claim? Okay, all right, let's see this. Assume the population variances are equal. Look at the very last statement. Okay, so the very last sentence, it says population variances are equal. So that last part is telling us to click on the pull variance. We have to pull the variance because we have a reason, they told us, to assume that population variances are equal. Everything else is the same. You see, they're giving us x bar 1, SM1, and the sample sizes. So I'm going to stop this. And I'm going to go to my StatCrunch. And I'll do what popped up over there? I'll start from opening it again. Stat, Tstat, to sample, click on summary. And in this summary, let's go ahead and enter those summary in here. So mean is 0.48. The standard deviation is 0.05 and sample size is 30. Next, mean is 0.51. Hey, I don't know, is this significant? 48 cents is cheaper than 51 cents. But is the difference big enough for us to consider it to be statistically significant at 5% of significance level, right? 0.07, and the sample size is 32. All good. Okay, what do you do with this box? Should we pull variances? Yes, why? Because assume population variances are equal. If they are unequal, don't click on it. If they are equal, you click on this. Okay? Alrighty. Always assume the null hypothesis is that they are equal. Okay? The null hypothesis is assuming the population averages are equal. So you're not going to change this to something else. You're going to always assume that it is equal to 0. Okay? Now, remember they said this manufacturer said their miles per cost per mile is less than, right? They said they got this cheaper deal. So what you're going to do is you're going to have to subtract and get a negative value. Why? Because if theirs is cheaper, okay, cheaper minus expensive, small number minus big number, wouldn't that be a negative number? And negative number is smaller than 0. That's why the alternative hypothesis has to be mu1 minus mu2 is less than 0. And that's all. You just need to click compute. Whoopsie daisies, I need to give you the picture of this. Because you know, some students are just going by the Google slide. And for those students, I want to show them how to get this output table. Okay, so, oh, sorry, I think I skipped the slide. But the slide that I skipped just talked about the sample sizes were both at least 30. Got the hypothesis all set up for us, but we already did it. So over here, let's go ahead and put the output table. If I click on compute, here's a table. I'm gonna go ahead and copy and paste it over here, and we'll talk about this. I already have the answer filled out, but it says p-value is smaller than alpha. Is it really? What is the p-value? P-value equals, let's read the number, 0.0291. Oh wow, look at that. That is very small. That's like about 3%, isn't it? If you round that up, that is approximately 3% or 0.03. That is smaller than 5% or 0.05 because we have this beautifully small p-value. What do we get to do? We get to reject the null hypothesis. Yay! Because the p-value is smaller than the alpha level, we get to reject the null hypothesis. Now, null was assuming that they were the same. We reject they are the same. We move on to the alternative that they are different. In fact, we get to actually believe what they were saying. So take a look. I'm so happy. There is enough evidence. We have enough evidence, and that evidence is that small p-value. I'll underline this. There is enough evidence at the 5% level, not at 1% because 3% is bigger than 1, but at least 3% was smaller than 5. So at 5% level, we have enough evidence, okay, to support the manufacturer's claim that the mean driving cost per mile of its sedan is less than that of its competitors. That is a great news for this company, right? They have, and I'm glad they went with 5% because if they went with 1%, I would have probably had to say I failed to reject. But that was it. That was 2 examples. One where you had to pull variance. The other, we didn't have to pull variance, but you just saw 2 examples of doing 2 sample t-test with summary only. So if you want me to go over how to do this t-test with data, which is, I think is even easier because you don't have to enter anything. Okay, so email me if you want to see them, but I'm going to stop this video here because I will come back and talk about how to construct confidence interval, t-confidence interval to compare population means, okay, in my second video. Okay, so I'm going to stop this now.